Yes, it is. We're not gonna have more than 4 weeks.
Are we zooming tomorrow?
Maybe some batch tomorrow.
Alright.
And I'll probably Zoom on day. Just for anybody that wants to, even though we don't have those.
Okay. And the test is due this coming Sunday, right?
Probably have it due Monday.
Monday.
Got a homework problem, you got questions, so I need to look at it. Well, we're waiting for everybody to show up.
I think I'll be okay after breakfast. I sit down today.
Temperature, do you think it's at?
Fahrenheit?
Celsius.
I don't know Celsius that well.
All right, Fahrenheit.
150, maybe close to 200. I could convert to Celsius if you want me to, but
Boiling temperature for water.
I want to say it was at 100. 150. Fahrenheit, not Celsius.
100 Celsius, probably pretty close.
Is this what we were supposed to do last Saturday?
Yes, one of them. Trying to get us to do the field trip to the mine. If I can just get transportation figured out for the high school kids. I don't have any problem with you guys because I can transport college kids. I just can't transport high school kids. We had a fatality about 3 years ago. It's high school kids. They won't let us transport them anymore.
I was gonna say Miami has those vans. Not you don't have to take like a big buses or stuff that many high schoolers. You could probably take a van.
Yeah, that's what we're gonna try and do. I've got reached out to Globe. Miami said they couldn't accommodate us. Hoping Globe can.
Yeah.
Where is everybody? Usually Tricia's here.
Yeah.
I'm on Zoom. Hi.
There's somebody.
Oh, you are doing it too.
My kids are home on break, so I have to be home.
Okay, I was wondering, where's Tricia?
Not feeling too good today.
Right.
I fell asleep at like 4 a.m.
All right, well, you may have to, might be me and Angelina this morning.
Brooke said she's supposed to come, but I think she had taken this to school.
All right, well, you can start your lab. We are doing calorimetry. We're gonna find the specific heat of a metal. So if you want to get a piece of paper, you're gonna have to collect data from whoever is here collecting it for you. So we're gonna start out by measuring out 100 milliliters of water. And let's see. And we need the temperature of the water. So initial temperature of the metal, final temperature of the metal. Initial temperature of the water. Final temperature of the water. So if we have 100 milliliters of water, what is the mass of the water?
100 milliliters.
All right, so we know the water should be 100 grams. And the specific heat of the water? Remembers that number? Come on in. Morning. Remembers the specific heat of the water? 99. That's temperature. 4 point.
184.
Yes, there we go. I knew somebody would remember it. 4.184 joules per gram degrees Celsius. And we're gonna find the specific heat of the metal. That is our purpose. This is our data. All right, we got 3 groups. So the first thing you have to do is measure out 100 milliliters of water. You want to weigh it, you can weigh it too. And go ahead and put it in your water in your cup. After you measure out 100 milliliters, pour it in the cup, and then we need the temperature of the water.
You put it in there.
You would rather weigh it? Got a balance over here when you can weigh it, I'd rather weigh it.
We put it in the.
We're doing our calorimetry now.
We put it in here.
Put it in the graduated cylinder to get 100 milliliters. The bigger is the least accurate measuring device we have, other than something that we know measurements.
So.
No, it's not.
You're doing a fine job. We got 100 milliliters of water. Right. Do not melt the thermometer.
I know, well, they'll do the thing with the restrict. But it's, you know, what it is. No, that's really what it is.
You don't break yet, Mary? You guys don't have school this week? That's why you get to come today. That's good. All right, get your water measured out. All right. Put it in your calorimetry cup, which is your styrofoam cup. And we need to get the temperature stabilized. You can take the lid off. What's that? 100 milliliters. Or you can put a styrofoam cup on the balance there.
No, they do that. I'm getting all started. No. Oh, we're gonna get it today, probably.
All right, so you people on Zoom, we measured out 100 milliliters of water. Which weighs how much?
100 grams.
We have 100 grams of water. Specific heated water is 4.184 joules per gram degree Celsius. We're going to find out what the temperature changes to when we add the hot piece of metal. So the first thing we're going to do is Q equals MC delta T for the water. Then we're going to do the same thing for the metal. So using that same equation twice. The mass of the metal, we're going to find out after it cools down because I forgot to weigh them before I put them in the hot water. We can do that. All right, so after they get the water stabilized, should be probably around 20 degrees Celsius. Then they're gonna add a hot piece of metal to the water and let it or heat up the water, the metal will cool down until it stabilizes the temperature. So that is what they're doing right now. So pick your lab. Looks like Issa's all alone, so you can help Issa. You got 10 people helping you, Issa, on your lab group.
That's amazing.
Yes.
That's great.
You're also on camera. Live. Now you're gonna get a piece of metal. You're gonna drop the piece of metal into the styrofoam cup. You're gonna stir it, put the lid back on. You're gonna transfer it very quickly. So you probably want your styrofoam
After
cup
you put them
over there.
here.
A little lid back on.
What
And then
lid?
or you can leave the lid off, but you have to like measure it to find the like that's 19 degrees Celsius.
So let's see. There we go.
Oh wait, that's hold. Do we need the other? Do we need that?
Yes.
Which other one? To measure temperature when we're well, yeah, we can put it in over there. Oh, I'm gonna put it in like that. So it's let me grab it. Let me grab the thing.
Was I supposed to put the water in
Yeah.
here?
Put the water in there and then you'll put it in the, put your thermometer in it and find the temperature.
Soon this works without a battery. Or without plugging in. Just wait it. It's 19 Celsius, so it's the standing water.
Alex.
Ready? Yeah.
It's gonna stabilize. So, you know.
Oh, will it burn a hole in the styrofoam?
Nope,
No, the water will keep it from getting there. Oh, okay.
then just let it cool until it stabilizes.
21.2 is the highest. Oh.
Where did it start at?
19. No, it's at 21 degrees Celsius. It's staying there. I've got one.
Issa, what temperature do you have?
I got 17.4 degrees Celsius.
Thank you.
You're welcome.
3.
After you measure the temperature.
Of the standing water.
Yeah.
You press the play button though. You press the play button. If you press a little play button in the corner and then measure it, it'll give you your exact measurement. Yeah, just stick it in. Should be 19. I think it's right. Oh, so you have to let it stabilize. Just sit there. Yeah, just let it sit there.
I got 17.2.
Just leave it.
I got 17.2.
All right,
It's kind of
that's your temperature right now?
Yeah.
Okay, so now you get a piece of metal and put it into your styrofoam cup. Does that metal cover all the water?
yeah, almost out of it.
Okay.
22.1. That's the highest. We'll put the highest and then stabilize like 20. Yeah. Okay. Yeah, so then you have
I can't get it. I'm sorry.
easy pencil.
This is sorry. Well, and then you put them out.
Yes. Yeah, put the metal in and then You gotta put this over with that other one. So have this ready. And then put that metal in, put that over and watch the temperature rise.
So. let's see. And yours at another 100 milliliters, so do 200 milliliters. You have to use the polymer.
Throw the metal back in there for that.
Oh. Is it done?
Yeah.
Yeah. Put it in. Okay, so I guess you're okay. Oh, okay, they got a smaller one. Oh, okay. Okay, swirling. So you make sure that that's the next thing.
Is it? I think it's.
There is the temperature of your water. Now you can find the change in temperature of your water. You know, mass of your water. Thank you. Your water. And then by the change in temperature, how much.
Zoom people, I got 20.2 after I put the metal in. That's the temperature I got after I put it in. I got 20.
22,
20.2.
and that's the highest point,
Which one?
or sorry. This is like your highest temperature was 20.2.
I think so.
Just go
Oh, no,
to
it was
anal,
19.4.
go to analyze. Let's see. Statistics. Temperature. And so give you your max temperature and your minimum temperature.
Oh, okay.
So did you start at around 15 degrees?
I started around 17,
Okay.
but I think that's what I got.
And then it looks like your maximum was 20.3. So what you had for your highest temperature?
Yeah.
Okay. So it changed about 3 degrees.
Yeah.
All right. Wait for your metal.
The minimum temperature would be 15.1. And then the max is 20.3 degrees Celsius.
Okay, over here and take your styrofoam cup over here. Over there. Yeah, you gotta get a piece of metal. And go ahead and grab the little one. Put it in, yep. Put your lid on. And go put your thermometer in there. Set it up. Yep. Yeah. All right, you know which metal you had?
I had a silver one.
Was it the one they just took?
I
It wasn't the long silver one, right?
nope.
Okay, you have your metal? So you're going to your metal? Know which one it was? Get it, you gotta weigh it. Unless you're using the same one, was it, you know which one it was?
No, not exactly.
I think it's that one.
You use the copper colored one,
No, I used the other silver one. There was like 3 in there.
so they're doing the. Green and Michael have the dark silver one. Let's start with the one. My use. The long one.
It's that one.
Yeah, I think I used theirs.
Okay, so yeah, set it there, let it cool down, and then weigh it in the balance.
So that,
That's the temperatures, the final temperature of the water and. All right, you got yours, Issa?
Yes.
No, can you see the board?
It's just kind of out of focus and far away.
All right, I'll see if I can get this screen to work. Don't know if that was gonna be any better or not. Which screen do you see better? White screen or black screen?
I think the black might be better because it's closer.
All right, okay, so you're gonna need to weigh your metal. Once your temperature is done. And weigh your metal. So did you already weigh your metal? Where's your metal? No. So just take it out and dry it and go with it. You get the final temperature. All right, so just take out your metal. And weigh it. Put that one over there. Yeah. Is it on?
No, it's a big one.
So, vertically, like in final temperature.
Or final minus initial.
So would it be negative or positive?
It doesn't matter.
Oh,
So it's usually final minus initial. So it depends if you're doing the water or the metal, because the water is going to gain temperature. The metal is going to lose temperature. So one's negative, one's positive.
So the water
But
is gonna be positive.
If you just leave it as absolute value, that's okay.
Thank you.
You're welcome. Okay, who wants to use their data? All right. So mass of water, Issa.
Um. Oh, 100.
All right, initial temperature of the water.
15.1 degrees Celsius.
Final temperature of the water.
20.3 degrees Celsius.
And specific heat of the water.
1 more.
Is that the person?
That's the 4.184 joules per gram degree Celsius. All right, so what is your change in temperature for this one?
Wasn't it 3?
Started at 15.1 and went to 20.3.
5.2 degrees.
Now you can use the equation that we love to use in this chapter. Q equals MC delta T. And find the energy of your water. So the only difference for all of you should have 100 grams. Because you used 100 milliliters. The only difference is going to be your change in temperature. Specific heat is the same. Where's your paper? Where's your paper? And be by. How you turn it in?
Oh, that's a good.
Yes. That is a good point. What'd you do with Grace today?
Oh, so
All right. You guys want to have school either this week? Yeah, Dr. Chairman told me they have half days today.
This whole.
No, I'll probably Zoom if anybody wants to Zoom, just for a review. So there's no formal class. I'm still waiting for Globe to get back to me. Miami said no, so now I'm looking at Globe, see what they can do.
I don't think so. It's gonna be much else. More than mine.
They should have like a van that can hold. like,
Oh, we have.
up to
the
2
vans.
people.
Yeah, man, just as long as like they can get somebody who can like Saturday.
Right.
It used to be a lot of giant.
Yeah, they don't have a CDL license. They won't let me drive high speed goods.
What?
College won't let me drive high speed.
Oh,
goods.
all of them. Without a CEO.
Yeah.
Did you put? That's in
Just
the.
get my like freaking hold on.
No, we need my car.
It's such a unfortunate.
Did you get a value for that?
2,175.68.
2,176. That work?
Yes.
4 significant digits. All right, what'd you get for your group? Now, this is just the mass of your water times the specific heat of water times the change in temperature of your water.
Love you. I have to go to school.
Okay. So then you calculate that and see what that is.
600.
All right, so keep that number. So this is the energy from the water. Now, did the water get hotter or colder? So if the water got hotter, what happened to the metal? All right, so now we're going to find out what happened to the metal. So here was our little calorimeter. We have water in there. And then we dumped a piece of metal in here. And the metal heated up the water as it cooled down. So all of the energy from the metal went into the water. That's why the water heated up. So the metal is exothermic, releasing its energy. The water is endothermic, absorbing the energy. But the amount of energy that the metal gives off has to be exactly the same as the amount of energy that the water absorbs. So we know that this value has to equal the mass of the metal times the specific heat of the metal times the change in temperature of the metal. So 2176 joules, or whatever you got for your problem, equals the mass of the metal. So Isa, what was the mass of your metal? 55.7 grams. The specific heat of the metal, we don't know. And the change in temperature. So the water or the metal went from, what was the initial temperature of the metal? Yes. What temperature was the metal at? Or where did you get the metal from? So if you know the temperature of the boiling water, you know the temperature of the metal. I actually need it before because I turned it off.
Would it be like 98 if the water's boiling?
Close. Anybody measure the temperature of that water or record the temperature of the water? Braden, Michael, Levi, Preston? The temperature of the boiling water? And what was the temperature of boiling water? All right, so nobody knows the initial temperature of the metal. So Kendra is probably close. What'd you say it was? Did you look at it? All right, so we're going with 96.1. I think the highest I saw was 96.4. So the water in this room today is boiling around 96 degrees. So what was the final temperature of the metal? So there's your thermometer. After you put the metal in, it reached equilibrium. So the final temperature of the water has to be the same as the final temperature of the metal because they're now at the same temperature. So whatever you got for the final temperature of the water has to be the same as the final temperature of the metal because they're in the same styrofoam cup. So what was the final temperature of the metal?
20.3.
And so the change in temperature of the metal.
$75.8.
Now I know the change in temperature of the metal was 75.8 degrees Celsius. Now Anne Marie had a good question because she said, is this negative 5.2 or is this negative 75.8? One of them is heating up, one of them is cooling down. So one of them is really negative, the other one's positive. But we also know that the energy that's given off by the metal goes into the water. So one is exothermic, one's endothermic. So the two negatives will actually cancel each other out. So if you just go with absolute values, you don't have to worry about the negative signs. So we know 2176 joules equals 55.7 times specific heat of the metal times 75.8. So find the specific heat of your metal. And we had. So what color was yours, Issa? Alright, so we're going dark silver. So Levi, Preston, Kendra, what color was your middle?
Silver. Silver.
And anybody have the third one? Alright, so a copper color. Alright, go ahead and figure out your specific heat. And when you get it, you can put it on the board. Makes sense. Yes. So 12.2. Yes.
I got 0.515.
I got 0.099.
So Jennifer, I multiplied 55.7 times 75.8, which is 4,222.06. And then divided that out on the left side, which was 2176.
What about the 5.2 change in temperature? Doesn't that have to be on there?
So the change in temperature was 75.8 because we started at 96.1, the boiling spot of
Oh,
water.
that's what I did. I put the wrong temperature numbers.
And then the final temp was 20.3. So the difference between those was 75.8. So I just did 55.7 times 75.8. And then 2176 divided by that number. And I got 0.515.
Okay, let me try that again real quick.
This is my initial temperature. And this is the change of temperature, and that's the news.
So you don't know. Mass of water is 100 and the sea of water is 4.184.
Okay.
The change in temperature is 3.2. All right, so what did you say over there on Zoom?
I got 0.515 and Jennifer's double checking.
And which one is that for?
For the C for metal?
For Issa's?
Yeah.
Dark silver, light silver, or copper colored? Are you working with Issa?
Yes.
Okay, what was your number again?
0.515.
Get that, Issa?
Brooke, did you say 0.515?
Yes, ma'am.
Okay, cool. That's what I got.
Okay.
I love the same one, so
You get more contingency.
Yeah.
I got the same answer.
Is this one?
Yeah.
Right. Rating, Michael. Right, you guys are in charge of.
One, so it's one.
You get good.
Oh, you did it. Yeah, you did it so that I could do it the first time. I did it for the requirement too, so then that's it.
Alright, which one was yours?
Like this.
From the lake river.
Morning. Morning, how are you doing?
Good, how are you?
Pretty good.
I know you're running back to basin after this,
Yes,
in between. for a couple of minutes and talking.
sure. I'll be happy to. You're welcome to come and join us for a few minutes.
Yeah.
We're doing calorimetry. Glad we get to see her every once in a while.
And so, you know, I mean, you want to come in person, but.
That's good, because my.
So I want to make sure. I'm on this side.
Sometimes you can do one shot once on a calculator, like. we're gonna do especially on
Yeah. Nine, four, five.
I think it's the other adaptation piece. Is.
Oh, it's not. Six, five.
She did work just as schools.
It's the same, I asked my.
Oh, okay.
Not the problem. I got a student that I'm going that.
Well.
You wanna go home?
Because each one was two different pieces.
Sponsor me and. This transfer. You can transfer. That's not.
Yeah.
I need to know. Yeah, I did actually.
So it's for Dan.
Well, I was like, let's go there. Like, I'll have a long.
No, you're fine. You're good. You can stay here. Where it's warm, you can stay here. where it's warm.
Okay, thank you.
Did you get a number? You got your number?
Yes.
Yeah.
Well, no, I want to see if I can find it before. Let's talk on it. No, there's still a little more. There's still a little bit more.
All right, there's the numbers we got. Braden and Michael, you guys still working on it? All right. All right, your next job is you have to match your answer with one of those four. Those are your four unknown metals. So yours is one of those four. You got to figure out which one is yours. And then you can find your percent error. Do you remember how to calculate percent error from our last labs? What is it, Issa?
Isn't it the percent times like 100 or something like that?
That's at the end, right? So it's the accepted minus experiment divided by accepted times 100. You'll notice zinc and copper are really close to each other. So how would you tell if yours was zinc or if yours was copper? What? Yes, the color. So that'd be a good indicator of whether you were zinc or copper if yours is close to one of those two.
Is FE 447 or 947?
Say that again.
Is FE 447 or 947?
447. Okay, those of you that had the dark silver, what was the mass of your metal? Or light silver, what was the mass of yours? What was the, when you weighed it, what it was, did it weigh?
65.
5, 7.
And for dark silver, what was your mass? And those of you that had the copper colored? All right, you guys get your grade then, Michael? What did you come up with? You still working?
Yeah.
All right, another big hint, is if you looked at your piece of metal, what does it say on that piece of metal?
A, one more A. So A would be the first one.
Unless I didn't put them in order.
Well, we got zinc. Or aluminum.
So what else does it say on that piece of metal?
Mole,
How many?
one.
So what is the weight of 1 mole? How could you find the mass of 1 mole?
Hold on.
You don't even need to take the bus, you could just,
6.2
right.
times
So
10 to the 20.
there's another big hint. So if you're at copper, it should have weighed 63.546. Should have been the mass of that copper. Now when you got 63.58, so that was pretty close. If you had, which one up here weighs 65?
First time.
Zinc weighs 65.39, so if your mass was around 65, it was either copper or it was zinc. And 55.7. The iron at 55.848. So that's another big hint on what your unknown was. So you got 0.515 for the dark silver, should have been 0.447. So now on your discussion section, you've got your procedure or purpose. What was your purpose today? Levi, what was the purpose of your lab?
Hopefully. I don't know. It's like water.
What did we find out?
What your metal was.
Alright, so it's to determine the unknown metal
Yeah.
by using specific heat. Then you had your purpose, that was your purpose, and you had your experimental section, so you're writing your narrative on what you did. Then you got your data. So. And then I gave you data for unknowns, so you can compare yours. Then your analysis. So in your analysis, tell me what are some things that would make it so that you do not get the perfect answer? Like, why didn't you get 0.447? Why'd you get 0.518? To 0.447?
The percent error?
Yeah, why is there even an error? What are some errors? And don't tell me that you didn't weigh it right. Because that's not,
Not measuring our boiling water.
don't tell me it's measuring your boiling water because those are really not errors.
You didn't use specific numbers, like the whole number.
If you're to 3 significant digits, you're probably okay. So it's not the temperature you're boiling water because that we had a nice thermometer that does a good job. It's not weighing the mass of your metal because they've got a balance of weights to 3 significant or 3 decimal places. So it's extremely accurate. So it's not in the temperature or the weight of your metal. So what would cause you to not get the perfect answer?
Maybe not completely measuring out the exact amount of water.
Alright, so if you didn't measure out 100 milliliters, but I'm assuming you're really good at doing that now. So it might be a tiny bit of error there.
Maybe the metal out one.
There's a good, because when you took the metal out of the water, where'd it go? In the air. So what's happening as it's in the air? It's cooling off and it's heating up the air. So you're losing energy to heat up the air instead of the water. So how long did it take for you to transfer it from the hot water into your styrofoam cup? So if it took a long time, you may have lost more energy to the air. And what can you tell me about this nice high quality calorimeter?
Well, it's like.
It's probably extremely low quality, but it's better than putting it in a beaker, right? So what happens if you don't put the lid on?
It'll start to heat up the air.
So the temperature, your hot water, instead of the going in, staying here and equalizing, now you're losing temperature, heat to the air. So those are some of the main things that would cause experimental error. So the transfer, your calorimeter, so those are things you can put in your analysis part. And in conclusion,
The metal was.
tell me what the metal was, yes, and what the specific heat of your metal is. Alright, and then I'll put a place on Canvas where you can upload it. Or just take a picture, or if you got it now, or you have to write out your purpose, your, all that stuff. So right now you get 10 out of 25. But you have your data. Alright, questions? So I'll turn that one in on Monday. Tomorrow we are zooming. Wednesday, I will also have Zoom if you want to. So it'll just be a review session for the test. And the test will be open on Thanksgiving Day. For your enjoyment. It'll be due on Monday. So you don't have to spoil your Thanksgiving. So Monday at midnight. Questions? All right, we'll see you Monday morning. Or tomorrow morning. I'll see you. All right, Zoom people, any questions?
Are you gonna have a copy of your lab paper available?
No, they're just handwriting it.
Okay,
So there is no handout. You just, it's a formal lab report, so typed. And then I'll put a place on Zoom where you can upload it, or on Canvas where you can upload it.
okay, thank you.
You bet. All right. See you tomorrow on Zoom.